Welcome back to Jennifer Chemistry Official, where we make chemistry friendly to all our learners. I want us to go through covalent bonding, which is a bond that is between nonmetals. It involves sharing of electrons. It is represented using a single line, where each single line represents a shared pair of electrons, meaning that where we have only one single line written between two nonmetals, that one represents a single covalent bond. Two lines represents two shared pairs of electrons, that is a double covalent bond, and three lines represent three shared pair of electrons, that is a triple covalent bond. In a covalent bond, each atom contributes to the shared pair of electrons. There is this type of a covalent bond known as the coordinate bond or the dative bond or the dative covalent bond, which is a type of a covalent bond where only one of the nonmetals contribute to the shared pair of electrons. So as we continue, the example that I will provide is one where a coordinate bond is represented. A coordinate bond or a dative bond is represented by an arrow. This arrow points from the atom that contributes the pair of electrons to be shared. The arrow represents a shared pair of electrons. Then we have the key, where a single line represents a covalent bond. And remember that single line represents a pair of electrons. Then we have the arrow that represents a dative bond or a coordinate bond, and again an arrow represents a pair of electrons. Then we have this question that was in the KCSE of 2011, paper 1, question number 28, where we have a diagram showing the bonding between aluminum chloride and ammonia. There is the diagram. Then you are told to name the type of bonds that exists in the molecule. So where we have one single line, that is a covalent bond. Where we have an arrow, that is a dative bond or a coordinate bond. So the answer to this question A is that we have, where we have the single lines, this one is a covalent bond. This other one is also a covalent bond. This other one is also a covalent bond. The same with this one is also a covalent bond. This other one is also a covalent bond. The same to this one is also a covalent bond. Where this one, where we have an arrow, this is the dative bond or the coordinate bond. So to answer this question, we have two types of bonds. We have the covalent bond, and we also have the coordinate bond. And then we have the coordinate bond or the dative bond. So that is the answer to that question. The other question is asking us how many electrons are used for bonding. So back to the diagram. To determine the number of electrons that were used for bonding, we check on the number of covalent bonds in that molecule. So we count the single lines. We have 1, 2, 3, 4, 5, 6. We have 6 single lines. And each and every line represents 2 electrons. And we have 6 of them. So times 6. So we have 12 electrons from the single lines, which are the covalent bonds. Then we have one more where we have an arrow, and an arrow, I said, represents a coordinate bond or a dative bond. And now that we only have one single arrow still representing two electrons, represent two electrons, and it is only one arrow, so that is a total of two electrons from the dative bond, and then we combine these two, 12 from the covalent bonds plus the 2 from the dative bond, a total of 14 electrons. So the secret behind there is just for you to count the single bonds where we have not single bonds but the covalent bonds where we have a single line. There are how many? There are 6 of them, and each and every single line represents a pair of electrons, so 6 of them times 2 electrons for each, so those are 12 electrons. Then plus one single arrow representing a coordinate bond, also representing 2 electrons, so 1 times 2, then you combine the 2, you get a total of 14 electrons. So that is how you are supposed to do that question. Next, we have examples of molecules that show covalent bonding. We have the phosphine molecule, the water molecule, and the ammonia molecule. Each of the above molecules can combine with hydrogen proton to form a coordinate bond or a dative bond, where we have the phosphine molecule combining with the hydrogen proton, forming a phosphonium ion, the water molecule combining with the hydrogen proton, forming the hydroxonium ion, and finally the ammonia molecule combining with the hydrogen proton to form the ammonium ion. So in our next lesson, we will begin with the phosphine molecule, and I'll be guiding you step by step on how bonding happens in a phosphine molecule and also in the formation of a phosphonium ion. So keep it right here. Let us meet in our next lesson. Here is a question from KCSE 2020 paper 1 number 8, where we were to state one property that makes ammonia react with the hydrogen ion. And for us, I have just added water molecule and phosphine molecule because they behave the same way as ammonia molecule. So the question reads, state one property that makes ammonia molecule, water molecule, and a phosphine molecule react with the hydrogen ion, which is also the hydrogen proton. It is called the hydrogen proton when hydrogen reacts as a group 1 metal, they are alkali metals, and by reacting as an alkali metal, it loses the only one electron that it has in the only one energy level that it has. Remember, for hydrogen, it can either behave like a group 1 metal, and that time it will lose the only one electron that it has in the only one energy level that it has, and by so doing it will be left by only one proton, now that in the nucleus it do not have even a neutron. So when it reacts like a group 7, that time it will react by gaining one more electron to the one energy level that it has. So if you are asked to explain how hydrogen becomes a proton, it is when it behaves like a group 1 metal, and then it loses the only one electron that it has. So it is then known as a hydrogen proton. Now that this hydrogen proton is coming in with no electrons, now that it had already lost the one electron that it had, it can then combine with ammonia molecule and even a water molecule and even a phosphine molecule, because each one of the molecules stated it has a lone pair of electrons onto which hydrogen ion or the hydrogen proton will bond. So remember, hydrogen proton is coming in with no electrons to share, and meeting ammonia molecule separately, a water molecule separately, and a phosphine molecule separately. And now that each one of them has a lone pair of electrons. A lone pair of electrons means that that pair of electrons that is not yet bonded to anything. So that is where the hydrogen proton will come in and attach itself. So the answer is that ammonia molecule, the NH3, the water molecule, the H2O, and the phosphine molecule, the PH3, each has a lone pair of electrons onto which hydrogen ion or the hydrogen proton, the H positive, bonds, as hydrogen proton do not have any electrons to share with any of the molecule. So once we go to the next lesson, where we'll be now dealing with the formation of a phosphine molecule, and in the process the formation of a phosphonium ion, I will be showing you the very easy steps that we can follow to achieve that. So keep it right here. If you're a new subscriber, welcome home. If you are a returning subscriber, thank you very much. And if you are not yet to subscribe, kindly do so. Subscription is very free. God bless you.